In this final classwork problem, we're asked to analyze and sketch a graph of the function f of x equals x cubed minus 6x squared plus 8x. This is really the culmination of everything we've been doing in this unit. We've been using the first derivative to find increasing, decreasing, relative mins and maxes, second derivative to find concavity, points of inflection. We're now introducing the idea of finding the intercept from the original function, and when we put all of that together, it should allow us to draw a rough sketch of what's going on with the function. So when we talk about the intercepts, basically what that's asking us to do is factor the original function, find what makes it 0. So the first thing I see with this original function is that I can pull an x out of everything. If I do that, it would leave me with x squared minus 6x plus 8. If I then factor that further, the x can stay outside and it can become x minus 4, x minus 2. For that reason, the intercepts occur at x equals 0, which makes this 0, x equals 2, which makes that 0, and x equals 4, which makes that 0. If I want to specific rate them as x, y points, it's x equals 0, y equals 0, x equals 2, y equals 0, and x equals 4, y equals 0. Now that I've correctly factored and found the zeros or intercepts of the original function, I need to move on to figure out what the derivative is going to tell me. If I take the derivative f prime of x, this becomes 3x squared minus 12x plus 8. Again, my goal here is to figure out what makes this 0. Unfortunately, this is a little tougher of a problem. It's going to be that way where when you're taking 3 derivatives, it's going to be really uncommon, or 2 derivatives, I'm sorry. When you take the original and the 2 derivatives, it's going to be uncommon that they all factor nicely. Here what I'm going to do is I'm going to have to use the quadratic formula. So to find the zeros here, x equals negative b, which changes it to a positive 12, plus or minus the square root of b squared, 144, minus 4 times a, which is 3, times c, which is 8. All of this is going to be over 2a, or 2 times 3. When I resolve what's happening inside of the square root, basically 144 is subtracted by 12 times 8. 12 times 8 gives me 96. 144 minus 96 gives me 48. This is all over 6. Those aren't really that fun to look at and try and figure out where that crosses 0. If I want to go a step further, I can say that 48 can be broken down into 16 times 3. So I really can make this 12 plus or minus 4 the root of 3 over 6. If I take 2 out of everything, that becomes 6 plus or minus 2 root 3 over 3. Basically, this is going to give me where I have my possible max and min, but it's definitely a bit of a tricky problem. So if I draw my number line, where this equals 0, this is 2 minus 2 root 3 over 3. This would be 2 plus 2 root 3 over 3. So I'm going to write it as 2 minus 2 root 3 over 3 and 2 plus 2 root 3 over 3. Alright, that's definitely confusing. I apologize. That said, let me plug in stuff from the regions. If I plug in something between these two, the best thing for me to guess would be 2, because this is subtracted from 2, this is added to 2. If I put 2 in here, I get 4 times 3 is 12. 2 in here, I get negative 24 plus 8. 12 plus 8 is 20, minus 24 is negative 4, so this whole region is negative. When I now try and look at something that's very big, let's try 10 for instance. 3 times 10 squared is 100, so 100 times 3 is 300, minus 120 is 180, plus 8 is 188, positive. If I do it for negative 10, I still get 300, now it's plus 120 plus 8, so that's going to give me a total of positive. What I now know is that at this point I have a relative max because it went positive to negative. At this point I have a relative min because it went negative to positive. I'm now going to take the second derivative, f double prime of x. When I do that, I get 6x minus 12, which factors to 6x minus 2. This is a little easier to draw my number line from. I'm putting in a point at 2. If I put in something smaller than 2, let's say 0, this would give me positive times a negative, so this would all be negative. If I put in something bigger than 2, say 4, this would give me positive times a positive, which is all positive here. So what I can take from this, increasing before 2 minus 2 root 3 over 3, decreasing between these two numbers, and then increasing again past 2 plus 2 root 3 over 3. If I look at what's happening with concavity, concave down before 2, concave up after 2. I'm going to grab my calculator real quick just to sharpen these numbers into ones that are actual decimals so that I can see where they would fit on a drawing. If I now do 2 minus 2 the root of 3 divided by 3, this one tells me that it's happening at 0.845. If I do it for the right side, that one's happening at 3.155. So you may have to use your calculator to find these specific ones for one of these derivatives. Again, it's hard to make it work out each time. I apologize for these weird numbers. That said, I now can make a general sketch. Within this sketch, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. What I know for sure is I have these 3 points on the graph. 0, 0, 2, 0, and 4, 0. I also know that I hit a maximum at 0.845, a minimum at 3.155, that it's concave down up till 2, concave up after 2. So here, where it's before 2, concave down and increasing. Here's concave down and increasing. When it gets to 0.845, so around here, it hits a maximum. At that maximum, it starts decreasing, but still concave down. At 2, it switches concavity and is now concave up, but it's still decreasing. It hits a minimum point here at 3.155, then continues to increase. For the remainder of the time, it's increasing and concave up. So this would be a little bit better if I went back and solved for what each of these maxes and mins were. I would know exactly where to go in the y direction for each of them. But this is the general idea of curve sketching. Curve sketching, which we were hoping to do as a unit activity, has 3 different parts to look at. Initially, where does it hit 0? Next, where does it have a max or min, and where does it change from increasing to decreasing? And finally, where does it have a point of inflection, and where does it change from concave up to concave, concave down to concave up?